Assalamu alaikum, dear students. How are you? So, welcome to the channel, the Physics Gurus. So, this is the series of all the definitions of O-level physics as well as IGCSE physics syllabus 2022. So, we are in the episode number 6 of the definitions, and in previous episodes we have covered the definitions up till first 10 units. Now in this episode number 6 or part number 6, we will cover the definition related with the unit number 11, thermal properties of matter, and unit number 12, kinetic model of matter. So let's start the definitions of unit number 11, that is thermal properties of matter. So the very first definition, the definition of the heat capacity. Amount of heat required to raise, so it's the amount of heat required to raise the temperature of a body by 1 degree Celsius or by 1 Kelvin is called as heat capacity. The symbol of heat capacity is capital C. The symbol of amount of heat is delta Q, and the symbol of temperature is delta T. So its formula is capital C is equal to delta Q over delta T, and obviously its unit will be, the unit of heat will be joule, and the unit of temperature will be degree Celsius. So unit of heat capacity will be joule per degree Celsius. So in this definition, only we have to mention the number 1 heat and number 2 temperature. So unit is joule per degree Celsius. Now, whenever the word specific is used in this chapter, we will always mention the mass of the body equals to 1 kg. What is the trick? Whenever the word specific is used, we will always use the mass of the body equals to 1 kg. So this is the basic difference between the definition of heat capacity and specific heat capacity. That in heat capacity there is nothing like that. We have not mentioned the mass of the body, but in the definition of specific heat capacity, we have to mention the mass, that amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius. So amount of heat, it's common between these two. Then temperature, it's common between these two. 1 degree Celsius, it's common between these two. But the thing which will differentiate between the concept of the specific heat capacity with the concept of heat capacity is the amount of the substance, that is 1 kg, or the energy per unit mass per unit temperature increase is also called as specific heat capacity. The general formula is Q is equal to mc delta T, or Q is equal to mc delta theta as well. So delta T and delta theta stands for change in temperature. And from here we can write the formula of specific heat capacity, that is equals to Q over m delta T. So another difference, heat capacity is represented by capital C, while specific heat capacity is represented by small c. So formula of specific heat capacity will be equals to small c is equal to Q over m delta T. So unit of energy is joule, unit of mass is kg, unit of temperature is degree Celsius, so its unit will be joule per kg per degree Celsius. Larger the amount of specific heat capacity, it will take more time to heat up the body and more time for its cooling. And if the value of specific heat capacity is smaller, then it will take less time to heat up as well as less time to cool down. Then the definition of different processes, three states of matter are there: solid, liquid, and gas. So the definition of melting is also termed as fusion. So the process when solid changes into liquid is called as melting. Boiling is also called as vaporization. So the process when liquid changes into gas is called as boiling. Condensation is the reverse process of boiling. In boiling, which state of matter is converted into gas? Liquid turns into gas, while in condensation, this is the reverse process and gas changes into liquid. So in condensation, the process when gas turns into the liquid, and the freezing or solidification is the reverse process of melting. Freezing is also termed as solidification. So the process when liquid changes into the solid. In these two processes, heat has to be provided, while in these two processes, heat is being emitted or released during this process. Now, a very important definition, and usually this definition is written by most of the students in the wrong way. And what they are supposed to write, whenever the definition of melting point is being asked, they are supposed to write the definition like this: the point at which solid changes into liquid. So that definition will be crossed straightway, because melting point is not the point, rather melting point is the temperature. Boiling point is the temperature. Freezing point is the temperature. So melting point, the fixed temperature when solid turns into the liquid. The boiling point, the temperature when liquid turns into the gas. And the freezing point, the fixed temperature when liquid turns into the solid. So usually melting point is 0 degrees Celsius, as well as freezing point is also 0 degrees Celsius, and the boiling point of pure water is 100 degrees Celsius. Then here comes the definition of evaporation. The changing of liquid into vapors from the surface of liquid without heating is called evaporation. In this concept, liquid turns into the vapors or gas, but we have not provide heat to the liquid by ourselves. Heat is provided by the surrounding. So that process is called as evaporation. Then here comes the next definition, that is latent heat. The heat, okay, whenever the word latent is used, it's mean we will always mention without changing temperature. Whenever the term latent is used, we will mention that temperature will remain same or temperature will not change. So the amount of heat required to convert solid into liquid or liquid into vapors at constant temperature and without changing temperature. So now latent heat of fusion. Fusion was the alternate name of the which process? Melting. So the definition will be the same, but only we will cut this part. So the heat required to convert solid into liquid without changing temperature, at constant temperature. And in latent heat of vaporization, vaporization was the alternate name of which process? Boiling. So the amount of heat required to convert liquid into gas without changing temperature. Now the definition of specific latent heat. So the term specific is used, so we have to mention the word 1 kg, and latent is used, so we have to mention the term without changing temperature. So the amount of heat required to convert 1 kg of solid into liquid or 1 kg of liquid into vapors is at constant temperature or without change in temperature is called as specific latent heat. And it is of two types: specific latent heat of fusion and specific latent heat of vaporization. In specific latent heat of fusion, obviously melting means solid will be converted into liquid, but how much solid? 1 kilogram of solid, but at which temperature? At constant temperature. And the equation for specific latent heat of fusion is Q is equal to M into LF, where Q stands for amount of heat, M stands for mass, and LF stands for latent heat of fusion. So formula of latent heat of fusion is Q over M. The unit of Q is joule, and the unit of mass is kg. So what will be its unit? Joule per kg. Likewise, the definition of specific latent heat of vaporization is there, and this definition is very simple as well. Vaporization is related with boiling, And excuse me, and the definition is very simple. Word latent is used, so without change in temperature. And sorry, the word we have to add over here is specific. So this word is missing from here. So you have to add this word over here. So specific latent heat of vaporization. So the amount of heat required to convert 1 kg of liquid into gas at constant temperature or without change in temperature. And its formula is the same as the formula of specific latent heat of fusion with the difference of F with V. So LF stands for latent heat of fusion, specific latent heat of fusion, and LV stands for specific latent heat of vaporization. Then thermal expansion. So the expansion of the solid, liquid, or gas on heating is called as thermal expansion. So gas expands the most. Gas expansion is greater than the expansion of the liquids, and expansion of liquid is greater than the expansion of solid. And what is the reason why gases expand most? Because there are less intermolecular forces between their molecules and distance are larger. So this is the reason gases expand most on heating as compared to solid. And fortunately, good luck to all of you that there are no definition in unit number 12, that is kinetic model of matter. So best of luck to all of you for your exams. And if there are any questions, post those questions under the comment sections of the video. Okay, stay blessed. Assalamu alaikum.